Okay, we're going to look at now at inverse functions. Now remember, when you solve an equation such as, for example, 4 equals 3x plus 5, you're reversing the operations in the equation 3x plus 5 to find the value in the domain. And the question is, what is x? That leads us to the range value of 4, or y equals 4. If the variable x represents the domain, and again, yes, domain, sorry, the variable x represents the domain and the y represents the range, okay? Find the inverse function is a process of solving for the range variable. So here we can solve for a particular value and thus making the range variable the domain variable and vice versa. The original domain variable becomes the range variable, okay? So that's what's happening. So again, when we solve something like this, what do we do? Well, for example, this is multiply the first order operation, say 3 times x plus 5. So reversing everything, we start at the last thing I did, which is I'm going to, instead of adding, I'm going to subtract 5 from both sides, for example. I add then the corresponding results. Here we got 4 minus 1 is negative 1. Here we get 3x. And now I'll divide both sides by 3 instead of multiply. So everything is reversed. And that's what allows me to find now the value of x. Okay, so inverse operations just means reversing everything. The current state of operations and reversing them. Now, so let's consider this for a second. Inverse functions displayed in tables, ordered pairs, and graphs. So we're going to, again, as usual, going to look at different ways of expressing this. For the function f(x) to have an inverse function, the function f of x must be 1, 2, 1. So I never want you to forget this fact, that you must have a one-to-one function, and we'll have hopefully some opportunities to keep forcing you to remember this fact. Now, the symbolism. The inverse function, the inverse of the function f of x is symbolized by the following. We write the f, then there's negative 1, and we write x, like so. Okay, now I particularly do not care for putting this variable x here, as you'll see why in a bit. So, but that's the symbolism. And so this negative 1 power does not imply, so f of inverse of x, because this means inverse, does not mean the following. So it's not the reciprocal. So sometimes people get confused and think of a number. In other words, what they're thinking about is the following. 4 raised to the negative 1 power is 1/4. Okay, so but why use the symbol there? Because this turns out to be a symbol for inverse, but this is called the multiplicative inverse. Okay, and we'll see later what this means. Okay, because again, I like to go back whenever I can, use arithmetic principles, and also you tie it to the algebraic ones. But again, this symbol does not mean this, but it does mean inverse. All right. Now, symbolism gone awry. Again, more symbolism. While this topic should be a simple concept, the historical use of the variable x and the variable y needs to be understood. Okay, so a problem arises when we start to be too strict with these variables. When the variable x has no meaning and the variable y has no meaning, then textbook authors treat x as always belonging to the domain and the y variable as belonging to the range. Okay, so no matter what, that's always going to be the convention. And that's okay for a lot of things. You know, sometimes I'm very casual about this as well. But it's not good if you're trying to learn the material, because then there's some scenarios where all of a sudden this convention presents a problem. And this is one of the cases. In practice, actual use of mathematics out there, right? Variables can belong to either domain and range. So fixing it as this one belonging to the domain and this one to the range is not a good idea when you're talking about actually using mathematics in practice. So if I had my way, the correct symbol used would be the following. Let the function equal f of x equals y be 1 to 1, right? And why do I want it to be 1 to 1? Because for a function to have an inverse function, the function f of x must be 1 to 1. Then its inverse function should be the following. Notice now I've introduced the x and the y here. No, notice here I did not. Sorry, even here I did not. But now I am, so I can really focus on something. So right now, this is your domain, and this is your range variable. But when I'm looking at the inverse function, it should be displayed this way. Where now, this is a domain variable, and this is the range variable. If I could only spell variable. So let me illustrate this a little bit with this mapping. The inverse concept of turning as a mapping. So what a mapping is, we do these circle things. And I'm going to define this as the domain. And everything here is the variable y. Let's say I've got 1, 2, 3. Great. And over here, sorry, domain x. Sort of giving the game away a little bit. So what's happening is, see these numbers, 1, 2, 3, they're defined by the variable x. And we have another one here. And then we call this the range. And let's say this, again, this defined by a y. So I'm going to go A, B, and C. Make it nice and simple. So the objects here are A, B, C. Over here is 1, 2, 3. Great. And then what does a function do? A function takes objects here and maps them over to the other side. So let's say 1 goes to A, 2 goes to B, and 3 goes to C. And this is the journey of the rule f of x equals y. Now, the idea here is that the inverse function will reverse this concept. You can see this is 1, 2, 1. What's happening now, if we're now going to talk about the inverse function, all right, this now becomes the domain. And now this becomes the range. And then basically we're just going backwards. All these arrows now are going to get reversed and go in the opposite direction. But they're still going to the same place. Well, same place meaning connected to the same object on the other side. So we still have the same ordered pairs. Almost. But now I'm going to call this whole thing the domain and this whole thing the range. But the variable names I'm not going to switch because this is somehow intrinsic to what this represents, and this is how intrinsic to what this represents. So really what I'm going to do is say, look, now we're going backwards. Now we're going to take the y's objects and map them over to the x objects. And that's the way it should look. So I mentioned this because, again, books don't do it this way. At least the vast majority don't. So somewhere in the past, domain. Make this smaller here. Range. And again, let's say, again, this is nice and simple, A goes to B, B. But then when we go backwards, we'll do the same thing. We'll call this domain, this the range, but also rename this X and rename this Y. So now on this side, you have f of X equals Y. And on this side, you have f inverse of X equals Y. So it maintains X and Y is always belonging to the domain, always belonging to the range, but that's kind of a silly thing in my opinion. I'm not quite sure. I'd love to have been in that meeting where all of a sudden this was done. I'm sure the people that thought of it, that were not confused by the concept, but again, if you're a student, sometimes this could be problematic.